Hello everyone. Today we are going to start Unit 9, which is titled Additional Trigonometry Topics. So we still have a few things over trig that we need to cover. The first thing that we're going to cover today is called the law of sines, as you can see here. And the law of sines is actually really cool. So you can use this law to find side lengths and angle measures of oblique, which means non-right triangles. So far, when we're using trig, we needed to have a right triangle. That way we could have opposite adjacent hypotenuse. Well, now we're going to look at triangles that do not have a right angle, so there's no hypotenuse. So basically just no right angles at all. This is the rule here. So sine of A over little a equals sine of B over little b equals sine of C over little c. You don't have to use all three ratios. For the most part, you're going to use two at a time, depending on what measurements are given to you. One thing I do want to draw your attention to is take a look at that triangle there. So see how there's no right angles, but I want you to pay attention to the notation. So if angle A is this angle right here at the bottom, then directly across from it, that is going to be side A. Then angle B, across from that is side B. And then angle C, across from that, little c. It has to be that way always. So the side and the angle opposite of it will be the same letter. We just use capitals for the angles and lowercase for the sides. Okay, but honestly, these are a lot simpler than what we've been doing lately, so I think you guys are going to like this. So just remember, sine of the angle over the side length. Sine of the angle over the side length, sine of the angle over the side length. So in our directions, we have 5 problems we're going to go over. It says find each missing measure and round to the nearest tenth. So you'll notice that I have a side length that has the letter x. So they want me to find that letter x. So the first thing I'm going to do when I'm setting this up is whatever you're looking for, so in this case it's at x, set that up as your first ratio. So that side x goes with its opposite angle, so that 104. So we're going to set this up as sine of 104 degrees over x equals, well, now it needs to equal something where you know both. You know the angle and you know the side. So luckily for us, that's the other two that we have there. So here's my other angle. Actually, let me use a different color. Okay, so here's my angle, 47, and across from it, my opposite side. So those are going to go together. So we're going to have it equal sine of 47 degrees over 15. So now our job is to solve for that x. So this is just cross multiplication. Remember, we cross multiply. So bottom on the left goes with top right. Top on the left goes with the bottom on the right. So I'm going to do that first. Let's do this part. So x times sine 47 is equal to, now the other diagonal, 15 times the sine of 104. Okay, again, we are trying to solve for x. So our goal is to get that x by itself. Right now it's being multiplied by sine 47. So in order to get that alone, we're going to do the opposite operation and we're going to divide by sine 47. And we need to do that to both sides of the equal sign. So x equals this entire expression. So we don't have to do exact numbers anymore. We're not going to have square roots and radicals and fractions anymore. You can just straight up type that into the calculator. So I think I have a calculator pulled up already. Let me see. Okay, so here's Desmos. And all I did was just minimize my screen so that I could fit it all on there. So this here, we're going to type it into the calculator. Just be aware that you have to be on degree mode. Okay, so 15 sine of 104 divided by sine of 47. And there's our answer. They told us to round to the nearest tenth, so this would be 19.9. So x equals 19.9 centimeters. Okay. Let's look at another example. So here's my new triangle, no right angles, and we need to solve for x. So always set up that ratio first. So starting with what they want you to find and the opposite angle. So that would be sine of 42 degrees over x equals. Now, you need to have it equal to something that you have both the angle and the side. So if you look at that 63, we don't know what that side is. So that's not going to work. Okay, so what if I have a side that's 28. My problem is I don't know what that angle is, but that's easier to find. So remember that triangles are 180 degrees, so we're going to have to do that first. Let's subtract the two angles that we already have. And whatever's left over will be for that angle. So let me get my calculator again. 180 minus 63 minus 42. So that leaves 75. So that means that this angle here has to be 75. It has to equal that 180. Okay, so I'm going to set this up. Sine of 75 degrees divided by 28. Okay, and then just like before, let's cross multiply. Let's solve for x. So our first cross multiplication will be x times sine 75 is equal to 28 times sine 42. We need to get that x by itself, so we're going to divide by sine 75 so that it will cancel. But we need to do that to both sides. So that leaves us with x equals, well, now we just need to type in that entire thing into the calculator. So let me pull that up again. Move this over so we can see. 28 sine 42 over 75. And that gives us, we're rounding to the nearest tenth, so 19.4. And they are measuring in feet in this problem. Okay, so we're going to do two more problems because we just want to keep up this pattern so that we make sure that we know what we're doing. Okay, so our third example, here's my triangle. In fact, that way I don't have to go back. Let's find that missing angle. So you see how that angle doesn't have a measurement? Let's find that first. So 180 minus 92 minus 65, that equals 23. Okay, so that angle is 23. Okay, so we're solving for x. Here's our x, and we want the opposite angle. So if you go across, my opposite angle is at 65. So I'm going to start off with sine of 65 degrees divided by x equals. Now I need one where I have both the angle and the side. Oops, so it looks like I did more work than I needed to, because here's my other angle, and then when I go across, I have the opposite side already. So this would be sine of 92 degrees over 11. So now let's do our cross multiplication. So starting here, x times sine 92 is equal to, other diagonal, 11 times sine 65. Okay, and if I want that x to be by itself, I need to divide by the sine 92. That will cancel, and I'm left with x equals, well, now I'm just going to throw all of that into the calculator so I can get a value for it. So 11 sine 65 over sine of 92. So 9.97, if I were to round that to the nearest tenth, I think it's actually going to round to just plain 10. So let's do that. It's just going to be 10. They're measuring in meters. Okay, another triangle. So let's first find that missing angle right here. So 180 minus 32 minus 35 is equal to 113. Okay, now we're trying to find x. And if you go to the opposite angle, it's at 35. So starting with sine of 35 degrees divided by x is equal to, and then now look for something where you have both the angle and the side. So I have this side 14, and I have that angle. That's the one that we just found. That's 113. So sine of 113 over 14. Okay, cross multiply gives me x times sine of 113 equals 14 times the sine of 35. Let's divide by sine 113. Leaves me with x is equal to, and now it's just a calculator problem. Okay, and this gives us 8.7. And this one is measuring in yards. Okay, so far all of these have just been straight up triangles, find the missing side. Our last problem is going to be a word problem. So how would they use this in the real world? Okay, so it says, a pilot began to flight traveling 80 miles northwest. To avoid a storm, he makes a turn, then returns back to his original location. So the diagram of his flight course is shown below. So if you see this picture, that's where he started, starting point. Went northwest for 80 miles. There was a storm, so he had to turn, and then he went back to his original spot. And they gave us some angle measurements there. So now they say, find the total distance of the flight. So this is almost a perimeter problem. If you want to know the entire distance, it's going to be his first spot, when he turned, and then his distance back. So we need to know all three sides. And right now we only have just one side. So since we're finding two different sides, let's label them two different letters. Let's say this is x and this is y. Totally arbitrary, I just made them up. So let us start with in alphabetical order. So say I wanted to solve for x. Well, x and its opposite angle are 15. So sine of 15 over x is equal to, well, I need one where I have both the angle and the side. Right now I only have that one side, that 80. Oops, let's use highlighter, that 80. Its opposite angle would be this one here, only, oops, we don't have an angle measurement. Easy fix. So remember, 180 minus 108 minus 15, since those were the two angles that were given to us. Okay, so that one has to be 57. So that's my other ratio that I'm going to set up. Sine of 57 over 80. So then we'll cross multiply. Divide by sine 57. And we'll get that x is equal to whatever that happens to be. So let's see. 80 sine 15 over sine of 57. So let's round to the nearest tenth. That's 24.7 miles. Okay, so that's one part of it. That's not the final answer, that's just one side. Let's figure out what the other side should be. So now if I wanted to solve for y, here's y. My opposite angle is 108. So sine of 108 over y is equal to, well, I need another ratio, and since we already figured this one out, see the blue part? Might as well just use it again, it doesn't matter. So sine of 57 over 80. Let's do our cross multiplying. Y times sine 57 equals 80 times sine of 108. Divide by sine 57. And then we would get y equals, so let's see. $80 times sine of 108 over sine 57. That gives me 90.7. Okay, so now I officially have all three sides of this triangle. I know how far it took for his first path, because they told us in the story that was 80. We figured out that this little piece is 24.7, and we figured his way back was 90.7. So if I want his total flight, I'm just going to add all those numbers together. So, yeah, total distance would be 80 plus 24.7 plus 90.7. And let's see what that comes out to. 80 plus 24.7 plus 90.7. Okay, now it gives us 195.4. So his total trip was 195.4 miles. I know I was boxing in all my answers, but really this is the final answer that they wanted. Okay, so like I said, this one, as long as you follow the formula, it's pretty easy. It's arithmetic, it's calculator problems, so I know you guys are gonna like this. So for now, that's all the notes for today. Just let me know if you have any questions. Bye, guys.